Again, we'll use a partial fractions decomposition to find this antiderivative. Our first step is to factor the denominator, as always. The trick here is that we have an x to the fourth, but this behaves just like a quadratic since it's an x to the fourth here and an x squared here. So it will factor, but the first terms will be x squareds instead of x's, since we need x to the fourth in the end. Well, 196 is 14 times 14, which is 2 times 2 times 7 times 7, so that's also 49 times 4. And the 49 and the 4 will make the 53. So we're going to have a 49, we're going to have a 4. If I want negative 53, they need to both be negative, which is great, since at the end there'll be a positive 196. We still get 90x squared. And then we need to simplify and factor more if possible. So that's 90x squared over x plus 2, x minus 2, x plus 7, x minus 7. And that is the fully factored form of the denominator. And we need to break that up using partial fractions. So we get 90x squared over x plus 2, x minus 2, x plus 7, x minus 7 is a over x plus 2, b over x minus 2, c over x plus 7, d over x minus 7. And apply our natural, the process that we always use. Multiply by the entire denominator. Gives me 90x squared is a times x minus 2, x plus 7, x minus 7, plus b, x plus 2, x minus 7, or x plus 7, x minus 7. We'll run out of space here, so we'll move down here, plus c, x minus 2, x plus 2, and x minus 7. And finally d, x minus 2, x plus 2, x plus 7. It looks long and complicated, but it's actually fairly straightforward, since if we choose any of our favorite values of x, we'll actually get rid of everything except for one of our variables. So let me just do that right in here. If I let x equal to 2, then I get 90 times 4. This goes away because I have an x minus 2. This one will not, but this one will, and this one will. So we're only going to have the b term. So 90 times 4 is equal to b, putting 2 in, gets 4 times 9 times minus 5. So what's going to cancel? So we're going to get b is equal to, let me put it over here. We're going to get b is equal to 90 times 4 over 4 times 9. And lots of stuff is going to cancel. The 4s are going to cancel, the 9s are going to cancel. All that's going to leave me is a 10. So b is equal to 10. If I plug x equal to negative 2 in, some very similar stuff will happen. And it will still get 90 times 4. This one will now cancel because, let's see, this one will cancel with a negative 2 because I have an x plus 2, I have an x plus 2, and I have an x plus 2. So the only one that doesn't cancel is the a term. So that's a times negative 4 from there. This with the negative 2 will make a 5. Oh, speaking of, sorry, I missed the 5 that's right here. We should have a 5 in the denominator. So that's 5, a negative 5 in the denominator. So we're end up getting negative 2. My apologies. Okay, so that will be 90 times 4. A, so where are we at? A, negative 4, plugging our negative 2 in. That's a 5, and that's a negative 9. So that tells me that A is 90 times 4 over negative 4 times 5 times negative 9. And again, we look to see what cancels. The 4 cancels, the 9 cancels, leaving a 10. Now the negatives both cancel, which is just 10 over 5, which is positive 2. if I let x equal 7, then I get 90 times 49 is equal to, this one will go away, this one will go away, this one does not. So c times 5, when I plug in 7, x plus 7 plus 2 is 9, and, well, that one does go away, so we don't need the c. The only one that does not is this last one. So actually, d times 7 minus 2 is 5, 7 plus 2 is 9, 7 plus 7 is 14. So that tells me that d is 90 times 7, that's the 49, over 5 times 9 times 7 times 2. 7 cancels. 90 and 9 make 10, which will cancel with the 5 and make a 2, which will cancel with that 2, so we're left with a 7. So d is 7. Lastly, if I plug x equal negative 7 in, I end up getting 90 times 49 is equal to, the only thing that will be left is our c term, and so that will be c times negative 7 minus 2 is negative 9, negative 7 plus 2 is negative 5, negative 7 minus negative 7 is negative 14. These are exactly the same things as we got right here, except for we're going to end up getting a negative because 2 of the negatives will cancel, leaving me with 1, which tells me that c is going to be negative 7 instead. So our integral was a over x minus 2, b over x plus 2, c over x minus 7, d over x plus 7. So we end up getting a was here, so that's 2 over x minus 2, plus the b, which is minus 2 over x plus 2, plus c, which is negative 7 over x minus 7, and d is 7 over x plus 7. Finally, these integrate as linear terms. They integrate just the way we saw previously, all as natural logs. And we end up getting 2 natural log absolute value x minus 2 plus negative 2 natural log absolute value x plus 2 plus negative 7 natural log absolute value x minus 7 plus 7 natural log absolute value of x plus 7 plus c. So the only trick here was factoring a quartic, an x to the fourth, and then it was just a little bit of a process to get all the values, but the same process as we always use.